last problem set, you learned how the distributive law can help you factor. We'll come back to the distributive law in a little while, but in this problem set, it's really reinforcing a lot of concepts you've learned this quarter. Especially recognizing the form, whether something's written as a product or something's written as a sum. Isn't that really important when you're trying to use the distributive law to factor or multiply? Anyway, so why don't you start off by hitting the pause button and working these problems. We'll go over in just a minute. Okay, here we go. So on the first one, let's see, you get negative 7 times 11 is negative 77. The second one you get negative 18. The third one you get positive 77, right? Now the next ones, let's see, you get, for D, I get negative 6mx. For E, I get negative 3x plus 2m. You can't do anything, right? They're not like terms. It's easier to multiply factors than it is to add terms, isn't it? Because to add terms, they have to be like terms. Anyway, let's do this. This one's kind of involved. We worked inside the innermost parentheses. This would be a good first step, wouldn't it? You add these, you get negative 2 inside the parentheses, but you write the whole problem down. And inside these square brackets, we get negative 12 plus 3 times negative 2. The next operation is to do the multiplication, which gives us negative 6, right? So I get this, write the whole problem down. We add inside the square brackets to get negative 18, write the whole problem down. Multiply, and the last step you add. I get the final answer of 31. Okay, good. All right, now next thing I want to look at, this is really important. Something we did earlier on, but let's come back to it. We were talking about terms. Remember, terms are numbers being added together. So it says circle the main terms. We really don't need that word main. It's just to emphasize that a term could be a complicated expression. A term doesn't have to be one number or one letter. For example, this is all one term, right? This is all one term. This is all one term. There are 3 terms. They're separated by a plus sign. Here, read it back. 3a plus 2 times the quantity a plus 3 plus negative 4bc. They don't want you to simplify it. They just want you to circle the main terms. 3a is a term. Since since everything is being multiplied, this whole thing is one term, okay? Even though you have an addition within the term, we still call this one term because the major operation is a multiplication. And this would be the third term. So this one also has 3 terms. Okay, they get rather involved, but if you read it back, it does help. This one, you have negative 2 times the quantity 5x plus 3y. So this is all one term because this piece is being added to this piece, right? This is negative 3x times this quantity. So this is a multiplication here. So there are only 2 terms in this one right here. Even though inside the term you could simplify, but they don't want you to simplify. They just want you to circle the way it's written. How about this last one? 3x yz plus 5 times x times 2 times y times 3 times z. All this is multiplication going on. This is all multiplication. This is all multiplication. There's only 2 terms. You see how it works? Let's do a couple more, then I'll give you some to practice. Reading it back does help, though, if you get stuck. This is 24x plus, so this is all a term. And this is negative 16 times the quantity of y plus negative 13. So this is all a term, too. There's 2 terms here. This one's sneaky. This is 3 times this big quantity. You understand this is all a product here? This is 3 times some big blob. In fact, I would say it's 3 times this whole mess. So this whole thing is just one term. Within that multiplication, there might be some addition, but we don't get to simplify it. We just want to see the way it's written. All right, you got it? Why don't you try these? Try these. We'll go over these in just a minute. Okay, in the first one, x is a term, negative xy is a term, and 5 is a term. There's 3 terms. Here, 3a times 5b is a term, and negative 4bc is a term. There's 2 on this one. This one is a term. This is a multiplication. This is all one term. You see this addition right here? And this is all one term because this is all multiplication here too. 2 terms here. There's just 1 term here. This is 3ab times the quantity c plus 4. There's 2 terms here because it's negative 3 times this quantity plus 16 times this quantity, so there's 2 terms. And there's only two terms here because this is 3 times 2a, that's a term, and this whole thing is a multiplication, so there's only two terms here. Okay, let's review some notation. Whenever you see a number, it can be written as 1 times that number. And whenever you see the opposite of a number, it can be thought of as negative 1 times just the number, right? This may seem really basic, but it's also really important. For example, there are times when you might want to think of negative 3 as negative 1 times 3. Taking the opposite or additive inverse of a number is exactly the same thing as multiplying the number by negative 1, isn't it? Okay, so when you have the opposite of 8y, you're multiplying it by negative 1, your final answer is negative 8y. These two things mean the same thing. Negatives in front means multiplication by negative 1. What about this? When you see a negative sign in front of a quantity, parentheses, remember this is a multiplication by negative 1. That's what we're just saying over here, right here. So this means negative 1 times this quantity. So lo and behold, it's really the distributive law, isn't it? You have to distribute it to each one, each term inside the parentheses. The common mistake would be to forget to multiply each term by it, wouldn't it? Anyway, so this one, let's see this one. You got a negative sign in front of this quantity here. This means negative 1 times the quantity. So the negative 1 multiplies each term. Now when you do that, when you multiply each term by negative 1, doesn't that change the sign? It flips it. If the number is negative, now it's positive. If the number is positive, now it's negative. If the number is negative, now it's positive. So that's a nice way to remember it. Okay, let's do some more of these. We can apply the same concept with open sentences. It says make into a true closed sentence. What do you multiply 3x by to get negative 3x? Why, it would be negative 1, of course, right? What do you multiply the quantity x plus negative y by to get y plus negative x? This is a little sneaky because you've actually changed the order here, but what you do recognize is the y becomes positive and the x becomes negative. So what number would flip the sign? Y negative 1, of course, you're multiplying both of them by negative 1. Alright, let's do another one. I'll give you some to practice. So these aren't too bad. Why don't you see how they work? Okay, here the question is, what do you negative 1 times what would equal this? Well, see this? This is kind of subtle, I think. This is negative 1 multiplying this whole quantity. So the quantity, when you multiply the negative 1 through, you end up with this. So wouldn't the quantity have to be a 3a plus negative 5b plus 2, right? When you distribute the negative 1, it changes all the signs. There you go. All right, try these then. Go ahead, hit the pause button and try these. Okay, on the first one, 3x is what times negative 3x? Well, you have to multiply by negative 1, wouldn't you? What do you multiply this expression by to get this one? Well, you notice each term that sign's been switched, so negative 1 outside the parentheses would accomplish that, wouldn't it? Here, what would you multiply this expression by to get this? Well, each term has now been multiplied by negative 1, so put a negative 1 on the outside. Negative 1 times what equals this? Well, it would have to change the sign of each of them, so it'd have to be a 3b plus negative b plus 1. That's what you need inside the parentheses. So, this idea of multiplying by negative 1, you could also factor out a negative 1. In other words, think of it like this. You're asking yourself, on number 23, you're asking yourself, okay, if you take this expression and you factor out a negative 1, what would be left inside? This negative 1 has to multiply each of these to get this. Negative 1 times what equals 5x? It'd have to be a negative 5x, wouldn't it? Plus, negative 1 times what would equal negative 9y? It'd have to be 9y. Go ahead and check yourself. If you multiply back through, you should get this, right? That's a little sneaky, but it does come up. It's a technique you do have to learn. It does come up later. Okay, I want to factor out negative 1, so on this one, you take the negative 1 out like this. Negative 1 times what is 4a? It'd have to be a negative 4a. Then to get 5b, you'd have to have a negative 5b, and then to get negative 11, you'd have to have just 11 in there. Alright, why don't you try these? Okay, so on the first one, if you factor out a negative 1, that's nice because it leaves both of them. So what you're left with is just negative 1 times the quantity 8x plus y. Here, if you take a negative 1 out of here, let's see, you'd have to have a 3p, right? You'd also have to have a 15s, and the last one would have to be a negative 9. Okay, if you take a negative 1 out of here, out of both of these, a good question is why would you want to do this? Well, there are times when it might come up. In terms of, in general though, the only time I would say for you to definitely do it is if each term is negative, then I would take a negative out. Otherwise, you don't have to do this. This is just practice. But there are times later on where you might want to do that. Take a negative 1 out and you'd have to have a negative m plus negative 7 inside, right? Take a negative 1 out of here, you'd have to have negative x plus y. Alright, we'll see you next time. Bye-bye.